Hi, welcome back to this lesson on trigonometry rules. We're now going to be looking at a new rule called the area rule. Have you ever thought about how we find the area of a triangle when we don't have enough information to use the regular area of triangle equals half base times height formula? That's what we're going to be doing today, the area rule. How do we find the area of a non-right angle triangle if we don't have the height? So the area rule is pretty simple. Even to memorize, it's pretty simple. It states that the area of any triangle ABC in this case equals half AB sine C. So because our triangle is triangle ABC, you'll notice A and B go here and the remaining letter is the angle C. So it's pretty simple to memorize. Can you guess what the next version would be? Let's see. The next version for the area is area of the same triangle ABC will be area equals half times BC sine of A. So we've covered all our letters A, B, C. Now I think you can definitely guess the third version. The third version will be half side A, side C, and angle B. What does this look like on the triangle? Let's look at the first one. The first one we have is half AB sine C. So if we're using the first version of the area rule, we're using side A, side B, and we're using angle C. And if you notice, these three units, these three measurements are sitting in a kind of a V fashion. So we have that side, we're using that side, and we're using the angle in between. Let's look at the second one. The second one is half BC sine A. So it's B, C, and this angle here. So for the second one, we're using that side, and we're looking at this angle here. So basically, we're kind of looking at that side, and that angle there. So you'll notice when we're using the sine rule, we actually need to be given the information in a specific way. We need to be given the side, an angle, and a side. So we need to be given side, angle, side, and the angle in between has to be the included angle. So let's summarize that quickly. So area is half AB sine C, or half BC sine A, or half AC sine B for this triangle here. And remember, we must be given side, angle, side, and it has to be the included angle. Okay, that's pretty simple. Let's see how we can apply this area rule to some triangles. Here's another triangle, PQR. Can you guess what the three versions will be for this triangle? Pretty simple, right? First one, area of triangle PQR will be PQ sine R. Can you guess the second version? Let's see if you got this right. Half PR sine Q. And the last version for this triangle will be half QR sine of P. Just remember again, if we were using the last version, it's Q, R, and sine of this angle. So we would be looking at this V pattern in this case. Let's look at one example. In this example, they've given us an actual values. They said the area of triangle ABC. We need to find the area of triangle ABC correct to 2 decimal places. So let's look at what they've given us. if you look at our diagram, we have this value here, which is little c. We have this value, which belongs to BC. So BC is 44 units, or in other words, little a is 44 units. And they've given us that angle B is 36 degrees. Now, do we have our side angle side? Yes, we do. We've got our side angle side. We've got our V pattern like that. We've got those two, so we can apply the area rule. Which version of area rule are we going to use? Remember our three versions of the area rule for this triangle: half AB sine C, half BC sine A, and half AC sine B. So obviously, we're going to use the one with A, C, and B. A, C, and B. So the version of the area rule we're going to use now is that version. Let's see how we're going to apply it by substituting it into the formula. So area equals to half AC sine B. Okay, and our A value was 44. Our C value was 40. And our angle B was 36 degrees. We're going to put this into the calculator. And if you put this into the calculator, we're going to get half times 44 times 40 times sine of 36. And our answer is 507,251. And remember again, we are rounding off to just 2 decimal places. So our answer is 517,25 degrees. 25 centimeters squared. Okay, so after the break, we'll practice more area rule.